find the exact value of the cosine of 15 degrees. I'm going to begin by, at least in the first quadrant here, labeling the angles that we are familiar with, that we can find the sine and cosine of without using a calculator. There's 45 degrees, and here is 30 degrees, and here is 60 degrees. But what we're looking for here is the cosine of 15 degrees, and that's not one of those angles that we have some experience with, but here it is. That's 15 degrees right there. And what we're looking for is, you remember there is a cosine and sine here. We're looking for the cosine of that angle, so that's the first component, the distance from the origin out to here. Now there are two different solutions to this problem. I'll call the first one here solution 1. And solution 1 uses something called the difference formula. And that works like this. If you want to find the cosine of 15 degrees, that's the same as the cosine of two angles that we know something about. And those two angles that we know something about are 60 degrees and 45 degrees. Now, if you use the difference formula, you will find that this is the cosine of 60 times the cosine of 45 degrees plus the sine of 60 degrees times the sine of 45 degrees. And all these are well known and defined, so let's get them one at a time here. First of all, what is the cosine of 60 degrees? Well, here is 60 degrees. The cosine is the first component, and that's 1/2. What is the cosine of 45 degrees? Well, here is 45 degrees. The first component here is the cosine, and that is, you can write it as either 1 over the square root of 2 or the square root of 2 over 2. The next term is the sine of 60 degrees. Well, here is 60 degrees. Cosine is the first component. Square root of 3 over 2 is the second component, so that's the square root of 3 divided by 2. Finally, the last term here is the sine of 45 degrees. Cosine is the first component, sine is the second component, and that is also going to be the square root of 2 divided by 2. When you simplify, these both have a common denominator of 4, 2 times 2 in the denominator, and what you get here is you get the square root of 2 plus the square root of 6 as a numerator. So there is the way you calculate the cosine of 15 degrees without using a calculator, using the difference formula. Now there is a second solution. Label this one here as solution 2. And solution 2 is something known as a half angle formula. Here's the way that works. If we want the cosine of 15 degrees, that's going to be the same as the cosine of 30 degrees divided by 2. 30 degrees is an angle that we know of. And if you go to the half angle formula, this will be plus or minus the square root of 1 plus the cosine of 30 degrees divided by 2. Now a little bit about this plus or minus up front. We can look at 15 degrees and know that the cosine function is positive. It's the length from the origin to right below that dot. And so we can drop the minus portion here and just work with the plus portion. So we can drop that, and we get 1 plus the cosine of 30 degrees. Let's go to 30 degrees. 30 degrees shows up right here. And what is the cosine in that case? It is the first component, and that is the square root of 3 over 2. Divided by 2. So finally, to simplify this a little bit, if you take these two terms right here, 1 divided by 2 is a half, and the square root of 3 over 2 divided by 2 is the square root of 3 divided by 4. So in this case, you have a square root inside of a square root. Now it looks, at least on the surface, that our two answers, namely this one right here, which was done with the difference formula, and this one right here, which was done by the half-angle formula, are different. But if you plug them into a calculator, you'll see that they're not. They are the same number. If you wanted to do that without a calculator, you could square both of these two quantities, and you would see that they are equal. So there is the answer to the cosine of 15 degrees by two different solution methods.